Hi guys, welcome back. So now we're going to start talking about how we describe, explore, and compare data using the measures of center. When you think about the measures of center, I want you to think about the mean and the median, or what we consider to be the center of the data. The center of the data is most important because it gives us one value, which is the mean, which is basically the average of the data values. Average is important oftentimes when you're looking for the average price of a home, the average price of a car, the average price of textbooks. So average can mean a lot to us. Now I want to show you that there are some important properties of the mean. Basically, the first thing that's most important is that when we talk about the mean, we're actually talking about using every data value in the data set. And the sample mean drawn from the sample population tends to vary less than other measures of center. Now, a disadvantage of the mean is that one outlier, that means a value that is greatly different from the values in our data set, can actually impact the value of the mean substantially. So if I have an error, data error, remember we talked about that in chapter 1, where I enter the value of 39, but it's supposed to be 93, it's going to drop the value of my mean. So it's going to change it substantially. What if I was supposed to have the number 39 and I accidentally entered 93? That means it's going to cause my average to go up. So with that being said, the mean is a non or not resistant value. It's not resistant. So resistant means that the presence of an outlier does not cause it to change much. But if it's not resistant, it means that presence of that outlier does cause it to change very much. So the mean is a not resistant measure of center. Now, it's important in this section that we start making notes about notation. So the first thing I want to bring to your attention is the notation you see on the screen. This letter E, and it's not an E. I always say E because students say, oh, Ms. Ingram, that's an E. It's not an E. It's actually called sigma. And sigma denotes the sum of a set of data values. So we're moving into Greek terms or Greek notation. The letter X is the variable that represents an individual data value. A lowercase n means it represents the number of data values in a sample, and the uppercase n represents the number of data values in a population. There are two equations for the mean. The first one that you're going to see is X bar, which means sample mean, and it's the mean of the set of sample values. So we're going to add the individual data values together and divide by the total number of data values in the data set. And for the second equation, you have mu. It looks like a U, but it's not, and it's pronounced mu. And it's the mean of all the values in the population. So we're going to add all the individual data values, and we're going to divide by the number of data values in the population. All right, guys, so we're going to stop right here. In our next video, when we come back, we're actually going to calculate the mean. I look forward to seeing you in our next video.